everyone, so it's good to see you all again. I'm Natasha and welcome back. So today we're gonna continue our fifth chapter and it's complex numbers. So today we'll be discussing about some few properties here with the properties of arguments. So here we have 4 properties to discuss, and after then we'll maybe discuss a question too. And and one more thing, in the previous video, we discussed about we solved the question, right? Which was related to the argument of a complex number. Yeah. So in this video, we'll be discussing about the properties and we'll solve the question which will be based on the property, okay? Okay, so let's get started. Okay, so first property which is here is this argument of z1 and z2, which is going to be, which is equal to the argument of z1 plus argument of z2. So in general, what is it trying to say is, how many number, if I'm going to say I have 4, or maybe let's say I have 7 complex numbers, right? I have total 7 complex numbers, okay? Complex numbers, and they're just written it like this way, okay? So I can write all those 7 separately through just this way, right? After writing the first, the argument of first complex number, then the argument of second complex number till the last one, right? So this is what the first property is saying, in which the argument of 2 complex numbers are being multiplied, and and here what we can see is the argument of these 2 sets, we're adding them, we're adding them. So that's what we can see, right? Okay, so let's move on to the second property. What is this? ARG. Okay, so ARG is for, the argument. So argument of z1 by z2 is equal to the argument of z1 minus z2, okay? Okay, so it's saying that we have a complex number and we're dividing the argument of those 2 complex numbers, right? And so if it's written in this way, then we can write it in this way. How? First I will write the argument of z1, then minus argument of z2. Okay? Okay. So let's say if I have a value here, okay? So I'm going to say this argument of, let's say I have 2 plus iota, okay? By 4 plus 2 iota, okay? Yeah. So this is all what is here, and so what we will write it like this way: 2 plus iota minus argument of 4 plus 2 iota, right? This is the argument, so we'll write it like just like this way, right? Okay, so let me just erase this one. So let me clean it. Okay, so let's move on to the third property, which is, so this third property is related to the conjugate, the bar, which I can also say. So it's the argument of z, the conjugate of z, or we can even say this as the z bar, okay? But what we're exactly talking about is the conjugate, okay? And we have already discussed about this topic, right? So we already know that how we will write it. So if we have a conjugate, whatever is the conjugate, if it's 3 plus 4 iota, then it's going to be 3 minus 4 iota, right? Right? Yeah? Isn't it? So that's what it's going to do. And here, if an argument of, the conjugate of this complex number is given to us, so that, that argument which was positive or any value, it will be in negative, okay? Okay, and that conjugate will be removed as, we have put it here, negative sign. Okay, so let's talk about the fourth and the last property. Then after that, we'll discuss a question. So what's in this property? So this property is related to the power, right? The exponents and the power, you can even say this. So the argument of this z to the power m, or I can just say z raised to the power m, which is going to be equal to m, m into the argument of c. Okay. So what we can see here is that the power which was with z, we just took it outside, and we just take okay, so what I can say is what we can see is easily understandable, and I've already written it, so there's no need to tell it in detail or in more detail. What was here, it was just the power which was here. I just took it out from this bracket, okay, and after this bracket it came out from this bracket, and just right before the argument of z. So what I'm saying is this power, if I'm going to say suppose it is z power 2, okay, so then this 2 will come out to argument of z, okay, just like this way, okay. Is this clear? If yes, then let's move on, okay. These properties were really easy, and one thing that whatever question we'll discuss right now, or it will be related to the properties of arguments. So, and I think I already told you this, so before, so let's just write the question, without wasting our time. Okay, so question, I'm only going to discuss one question, okay? So we're only going to be discussing only one question. So what is this question? So let's see. Find the argument of 1 plus iota by 1 minus iota. Okay, this is the question, right? Is this clear? If yes, then let's move on. Okay, so we have to find the argument of this complex number. So let's get started with our question. So let's say this is complex number z, which is equal to 1 plus iota by 1 minus iota. Is it clear? Okay, then let's move on. Okay, so just right after this step, what we will do is the first step, as we know, the 3 steps to find the argument. The first one is to, find that tan inverse. Second is to identify, the quadrant, in which quadrant is that complex number lying. And third, finally, where we find out our theta. Okay? Okay. Yeah. So, what we'll be doing right here is that, one thing I want to tell you that we can solve this question just by 2 methods. The first method is just, directly, by using the property, okay? And then the second one is by rationalizing. So, rationalizing is just common, and we have used it a lot of times. No, not too many times, just I think it will be the second time or the third time, I don't know. But we can we can use this rationalization in these kind of questions. So let's see first of all that which property is it. So what we can see here is that this property is related to this second one property, right? So what we'll be writing is this thing, okay? So first, this is the first method, okay? Okay, I'll just write it here. The first method. Okay, so now how will I write it? So to find the argument of this z, I'm going to write the argument of 1 plus iota minus the argument of 1 minus iota. Is this clear? If yes, then let's move on. Let's put them in brackets. Okay, so after this argument we're going to use the tan inverse thing, right? Tan inverse and y by x. So what's our y? It's 1, and our x is also 1. And here I can see it's actually the same. Oh, here I'm going to write the tan, okay? Not the argument. So tan inverse 1. So what we can see here is our y, the imaginary part is negative. So I'm going to say this negative 1 by 1, okay? Nothing else. Okay, so this is clear, then let's move on. So what we can see here is tan inverse 1 minus tan inverse negative 1, right? If it's clear, then let's move on. Okay, so till here we've done nothing, we're just like we have just followed the steps. Okay, so the next thing that I want to do is we know about this thing, so how about I just erase this thing and because I want to write something else there. Okay, I'm just directly gonna write I'm just discuss about the quadrant, and I'm just directly gonna write the theta, that's pi by what. Okay, so for this one we can say, so what we will say here is this is coming the first quadrant, this is coming, okay, so what we can see here is that our y. So we know that this is cos and this is sine, right? So our sine is negative and our cos is positive. So this one's lie in the fourth quadrant and this one in the first quadrant. What we can see is this, right? In the fourth quadrant. Just because our sine is negative and our cos is positive. ASTC, right? ASTC. So it's in the fourth quadrant. This one's going to be the first quadrant. Okay, whatever. So how will I write it in the form of radian form? We're finding the theta, right? So as far as we know, tan inverse 1 we write as the pi by 4. Here what we can see is this negative sign. So we don't need to worry. It's going to be actually the same value, but it's going to be just a negative. So minus will be same as this from here. Minus pi by 4, okay? Just the same. You can put it in bracket. So what we can see here is, I hope it's clear, okay? I hope it is clear. I don't like to write it again and again. So through this way, what we can see here is that our negative will be positive. So what will be here is pi by 2. So we've got our answer, and our answer is pi by 2. And we know pi by 2 is equal to 90 degrees, right? We all know that. Okay, how did I, just wrote it? It was pi, here negative was positive, pi by 4. I took the common, and here I got 2 pi by 4. And, I just canceled it. And what I got here was 1. And here 2. So this is how I got pi by 2. Okay, so this is totally clear to us, right? If yes, then let's move on to our second method. From where we will rationalize the same thing, okay? So that was the first method. Now we're gonna solve it from the second method, okay? Okay, so the second method is by rationalizing. Okay. So what I'm going to do is I'm just strictly going to write it. So what we can see here is this 1 plus iota. Let me come here, okay? This 1 plus iota by 1 minus iota. So how will I write it? So I'm going to take the positive value, right? So it's going to be 1 plus iota by 1 plus iota. And the last, in the denominator, I'll get the value squares, right? The square values. So, it will be like kind of really easy peasy. Okay? Yeah. So, let me tell you, after that, what we'll get is going to be 1 plus iota square plus 2 iota by 1 minus iota square. So, I just told you right now. Let me tell you how is it, okay? How is it? So, what I had here was, in this denominator, I'm going to have 1 square plus iota square, right? And 1 square will be 1, so that's why I said 1 minus iota square. Okay? Okay, is this clear? If yes, then let's move on. Okay, so I'll just, start writing this. So this rationalization method should be clear because, we can solve it. We can just use this method anytime, if we think that this answer, like, we can also find it, just by rationalization, like, just by using this method rationalization, right? Yeah. So, okay, so 1 minus iota square will be in the denominator. And here I'm going to have 1 plus iota square plus 2 iota, okay? If this thing's clear, then, what's left? Whatever's left is just really crystal, I'm not going to use those words, but I'm just directly going to say this. Okay, so first that I will cancel this. Okay, so in the denominator I had 1 minus iota square, right? So like that is totally understandable, and there was nothing to be confused. So what I had here was, what I had here was 1 square minus I square, right? And so 1 square will be 1 minus iota square as it is. I wrote it, and here I got 1 plus iota, right? So 1 was 1, right? And 1 plus iota was 1 plus iota square. So what I'm going to do is I'm going to cancel this, and after this, what's left? 2 iota by 2, right? Okay, if this is clear, then let's move on. So finally, what we had is iota left. Iota. Isn't this a little bit surprising? We only had a value iota left, right? So, as far as we know, if I'm going to write it in the form of the complex number, what am I going to get? I'm going to get this argument of, in the bracket, I'm going to get 0 plus iota, right? Because we have no real part here. We have only the imaginary part, right? Yeah. So the argument of 0 plus iota. And for kind information, we already know that this argument, which is 0 plus iota, we can write it in the form of this, the same way. But yeah, one thing, either, even if you're going to use the property or, just by rationalizing it, we will get the same answer. There will be no difference at all, okay? It will be a little different way, so like we find out the answer in a little different way, but, the answer is going to be same. So this argument, which we'll write as the same thing, tan inverse 0 plus iota we're having. So 1 by 0. And 1 by 0 is actually pi by 2. And so through this way, we got our answer 90 degree again. Because we all know that this tan inverse 1 by 0 is equal to pi by 2. Right? And I hope this is clear. And I don't think there's any need to be confused here, because what I did was really same. Here I got 2 iota, so I just wrote it just right. And in the denominator, how I got 2, 1 minus iota, okay? So 1 minus iota. So I had this minus 1, which was 1. So 1 plus 1, I got 2, right? Iota is going to be negative 1. And negative 1 and negative 1 will be positive 1 squared. And positive 1 squared will be 1, positive 1. So this is how I got 1 plus 1, 2. Okay? If this is clear, then everything's clear to us, okay? Well, that was it. And we have solved this question too. Or, just by using these two methods. And we have, so like our today's topic's done. So I think that's enough for today. So, that's all for today. And in the next video, what we'll be discussing about? We'll be discussing about quadratic equations. Yeah, we'll maybe discuss about the quadratic equations, and quadratic equations is a really interesting topic, just like the complex number thing. So finally, we'll get to our second real part. Okay, I'm not talking about this real part, which we have discussed in complex number. I'm talking about the real part. I can say, okay, so in this chapter we had only two things to discuss about the complex number and the quadratic equations. The complex number is like almost complete, like it's already completed. I think it's complete. So, we'll maybe discuss about the quadratic equations in the next video, but whatever. So, thanks for watching and have a great day.